You know, the massive AI models we see today, they're really just the tip of the iceberg. But to get to what's next, to power the future of AI, we need a genuine revolution. And not in code, but in the physical hardware that connects everything. The reality is, we've slammed into a fundamental limit, the challenge of moving data. And it all boils down to a problem of physics.
You know, this quote from Corning, it just nails the problem perfectly. The incredible demand from AI and high-performance computing is creating a massive data traffic jam. The traditional copper wiring inside our data centers, the very roads connecting our most powerful chips, they're turning into total bottlenecks. And that, right there, is the heart of the matter. The problem isn't just about writing smarter algorithms. It's literally about overcoming the physical limitations of electricity moving through copper. The longer that wire gets, the more the signal just falls apart and the more power it takes to shove it through.
Okay, so this brings us to the main villain of our story, the power wall. Think of it as the point where you just can't shove any more power into a system to overcome that signal loss. You try, and all you get is way too much heat and an energy bill that's through the roof. For the next generation of AI, hitting this wall isn't just a possibility, it's pretty much an inevitability with the tech we're using today.
So, here's the fundamental trade-off, laid out plain and simple. Traditional copper interconnects are just incredibly power-hungry. We're talking 15 to 20 picojoules for every single bit of data they move. Now look at the solution, co-packaged optics, or CPO. It slashes that energy cost by more than 75%, with a clear path to get even better. This isn't just an improvement, it's a complete game-changer for building sustainable and powerful data centers.
So what exactly is CPO? Well, the core idea is actually pretty brilliant in its simplicity. If distance is the problem, then you have to shrink the distance. CPO puts the components that turn electricity into light, the optical engines, right next to the processing chips, inside the very same package. That electrical journey gets shrunk down from centimeters on a circuit board all the way down to just millimeters.
Right, but CPO didn't just pop up out of nowhere. It's the result of a really rapid evolutionary leap. And understanding that is key to seeing where this whole industry is headed. If you look at this progression, you see a really clear pattern. As the optics get physically closer to the chip, the performance just skyrockets. Gen 1, or near-package optics, was a good first step. But then, by integrating the components onto the same substrate, that's what we call 2.5D packaging, boom, power consumption was cut in half. The later generations, which use these advanced chiplet and 3D stacking techniques, are promising absolutely radical efficiency gains while doubling data capacity with each step.
So this visualizes that journey inward we're talking about. We went from these clunky, pluggable modules you'd stick in the front of a machine, to putting the optics right on the same circuit board, to finally integrating them inside the same package. And that final step, 3D CPO, literally stacks the optics directly on top of the processor. Every single step gets us closer and closer to cracking this physics problem.
Of course, a jump this massive doesn't happen without some serious hurdles. The manufacturing is incredibly complex, and when you cram so much into a tiny space, you create huge problems with heat. Early products even showed failure rates 10 times higher than the traditional modules. Figuring this stuff out, that's what the entire industry is laser-focused on right now. It's the key to taking CPO mainstream.
So, whenever there's an opportunity this huge, you know what happens next? A new competitive landscape starts taking shape. This isn't just a technical race. It's a battle between industry titans and nimble startups, all racing to define the future of connectivity. As it stands today, the market is pretty much dominated by two heavyweights, Broadcom and NVIDIA. Together, they control over 60% of the CPO switch market. But here's the interesting part. They're playing the game in completely different ways, and their strategies are shaping the whole industry.
First up, you've got Broadcom. They've been the leader in networking chips for ages, and they're leveraging that position to build an open ecosystem. With their Bailey platform, their whole strategy is about creating a standard that everyone else can build on, even using practical things like external lasers, which actually make maintenance a whole lot easier for data center operators.
And then you have NVIDIA, which is doing, well, pretty much the exact opposite. As the dominant force in AI, their strategy is all about vertical integration. For them, CPO isn't just some component you buy. No, it's a deeply, deeply integrated piece of their entire stack, optimized for one thing, connecting thousands of their own GPUs in massive AI clusters using proprietary cutting-edge tech.
But listen, it's not just a two-horse race between Broadcom and NVIDIA.
The whole ecosystem around this technology is vast and incredibly complex, and it's all being driven by the insatiable demand from the world's biggest cloud companies.
To make something this revolutionary happen, you need incredible global collaboration. You've got the hyperscalers, think Meta, Google, AWS, Microsoft, driving the demand. You've got innovative startups like IR Labs pioneering brand new architectures. Right in the middle is the foundry, TSMC, providing the advanced packaging, working with specialists for every little component. It truly takes a global village to build this future.
Okay, so what does all this tech talk and strategy mean for the market? Well, the scale of this opportunity is, honestly, it's just staggering.
So right now, in 2024, the CPO switch market is really just getting its feet wet. We're talking about a modest $48.2 million. It might seem like a niche, but think of it as the seed for something way, way bigger.
Because, get this, by 2036, that market is projected to explode to over $20 billion. That's not just growth, that's the birth of an entirely new foundational layer of the whole tech industry. And this number right here, shows you the pure speed of this change. A projected compound annual growth rate of 37% between 2026 and 2036. That is just an insane rate of adoption, and it signals a fundamental shift in how we build our data infrastructure.
So after all that, what's the big takeaway here? CPO is not just another incremental upgrade. It's not just a little bit better. It is the foundational technology that's going to let AI keep growing at this crazy pace. It's the new plumbing for the cloud and the new backbone for the networks that are going to define our next decade.
Think about it. By moving from plain old copper wires to co-packaged light, we are fundamentally redrawing the boundaries of computation. So it really makes you wonder, once we finally solve this bottleneck and the speed of light itself becomes the next big problem, what incredible things are we going to build then?